and welcome to episode 16 of the Pi Podcast, the show by members of the Raspberry Pi community for the Raspberry Pi community. I'm Joe.
And I'm Albert.
And it's only been a week. What's going on? Why are we back? Well, you can't have missed the news that there's a Raspberry Pi 3 has come out. Big news. So we're going to do a special.
Yeah, we were fortunate enough to get invited to Raspberry Pi Towers by Liz. So we got we've in the can an interview with Liz as well, which is brilliant. But we also got to speak to Eben about the Raspberry Pi 3. So we'll play the interview with Eben and have a little chat again afterwards.
Yeah, let's hear that now. So we're here with Eben Upton of the Raspberry Pi Foundation, and I've got in my hand a Raspberry Pi 3, and I'm very excited.
Yeah!
So, can you tell us about it? What's different about it? What's better?
Everything is better about it. So the big things, I guess, new processor cores. So we've moved from a quad-core 32-bit Cortex A7 at 900 megahertz to a quad-core 64-bit Cortex A53 at 1200 megahertz. So that's kind of big headline change to the processor core. The other thing we've done, we've added integrated connectivity. So we've got 802.11n wireless LAN and Bluetooth 4.
And that's a big thing, isn't it?
Yeah, I mean this is a thing that people have been asking. People have been asking for since the start of the project, right? And it's something that's been kind of beyond our, beyond our budget, and also beyond our capability as an organisation. For the first 2 or 3 years, there's kind of a step change from making making a regular piece of electronics that only accidentally emits radio waves, right? Where you've got to do conformance testing to check that you're not emitting unreasonable amounts of the MI, to something which is intentionally a radio, particularly something which has effectively 3 separate radios on there. You've got the wireless, the 802.11 radio, you've got the Bluetooth Classic radio, and then you've got the Bluetooth Low Energy radio. So there's about 100,000, about 2 man-years of hardware design and about £100,000 of conformance testing expense associated with that.
Wow. So you say that's how long it's been in the pipeline then, for 2 years?
There's I guess 2 man-years of the radio side of it, probably about 2 man-years of engineering. So I guess 2 or 3 people for a little under a year. The project itself has been in the pipeline since the middle of 2014. So it's about an 18-month project. It's probably the quickest project we've done, with the exception of Zero, Zero was done in about 9 months. But for a complete new headline product, 18 months is the best we've ever done. Pi 2 was about 2.5 years.
And what were the big areas that took the most effort? Was it the radio?
It was the radio. So both the board layout, which was James Adams, and then the managing the conformance testing process, which was largely Roger Thornton here in the office.
And so when the Pi 2 came out, the kind of headline figure that you said was kind of a 6x performance increase. Is there a number that you're putting out there this time?
Yeah, so I think we're going for 50 to 60% increase over Pi 2, so roughly 10x over Pi 1. So that means 13 months. 13 months ago we were shipping Pi 1, so 13 months we've got a 10x. It's not a sustainable. We can't expect us to do that because we squeezed 2 generations in there. But it is kind of fun to have done a 10x performance increment in a little over a year.
Fantastic. And is the memory the same?
Yeah, so it's still a gigabyte of LPDDR2.
Okay, and still with the micro USB for storage.
Micro USB for storage.
Micro SD, sorry.
Micro USB for power, micro SD for storage, the 4 USBs, the 1000 Ethernet. So we've got, we've worked very hard to keep the rest of the design exactly the same. There's a lot of people who've designed around that form factor now, and we didn't want to mess with it.
And presumably cost as well was a big factor.
Yeah, we wanted to squeeze it into the $35 price point. To some extent, what is a Raspberry Pi is a thing that costs $35, and so there's never really any scope for us to grow that price. And to some extent, that's what defines the cadence of adding new stuff to the platform. As Moore's law and incremental optimization of the bill of materials and the production process take cost out of the platform. We're effectively every year trying to just drop some new feature in there using the money that we've saved.
So recently with the Pi Zero, it was in the UK £4, and then it looked like the sellers were doing it at $4.20 and now $4.25. I mean, that's
thanks,
component
Boris.
costs.
No, that's Boris. No, that's entirely Boris Johnson. The 420 to 425 is entirely Boris Johnson. Effectively, if you it's always $5. But you need a lot more sterling to buy $5 now than you did in November. Raspberry Pi Zero costs $5.
So for the 3, that pressure on the currency isn't going to affect it in the short term. It's still going to be, it's $35.
It's $35.
Do you have the target price for the UK?
I think the target price for the UK comes out between £29 and £30, including VAT.
Okay, that's good.
Yeah,
that's
pretty
excellent.
good. Yeah, that's pretty good.
Yeah, definitely.
Yeah, it's whatever a Pi 2 is today.
So we mentioned that it's 64-bit, but will 32-bit images run on it?
Yeah, the interesting thing about the 64-bit core is we're using the Cortex A53. We didn't pick it because it was a 64-bit core. We picked it because it was a better 32-bit core. We're primarily interested in running 32-bit code. We have a gig of RAM on there, so lots of there's not a compelling argument for more address space. You know, the main thing that drives you to 64-bit is more address space. Now, there is a possibility that the ARMv8, the AArch64 instruction set is more modern than the classic ARM instruction set we're using, and there it has more registers. For example, it's got 32 registers available to user programs. So it's possible that by being in 64-bit mode, you might get more. You might get some more performance out of the device, but we're going to wait for somebody to demonstrate to us that that's a good idea before we start turning on 64-bit support. So for now, we're running not just 32-bit, but we're actually running Raspbian. So we've got an ARMv8 core, and we're running basically an ARMv6 operating system on it. And the advantage there is, well, there's not that much benefit really to ARMv7 over ARMv6. And it means that we can have one operating system image that runs across everything from the very earliest Raspberry Pi Alpha boards, all of the Raspberry Pi 1 platforms, Raspberry Pi 2, Raspberry Pi 3, and 0. So it's a big effort, big saving of effort lets us focus. We still don't have an enormous amount of engineering resource here, so focusing all of our engineering effort on one operating system variant is important.
And the graphics, is that still the same?
It's still the same. We pushed the clock up a little bit. So we've gone from 250 megahertz to 400 megahertz for most of the graphics card. The main thing that buys us is 1080p 60 video. And we've pushed the 3D up from 250 to 300.
Okay.
Yeah. So.
And the last version of Raspbian had OpenGL experimental support. Will this be better on the Pi 3?
Perhaps a little bit. In that it does a significant amount of work on the CPUs. We're expecting that driver eventually to be competitive with the closed source driver on all Raspberry Pis from Raspberry Pi 1 onwards.
You say eventually. Is there a timescale on that?
Probably in the next 6 months. I mean, we really need to roll over to it. It is a great driver. It brings lots of capabilities that we haven't had historically. So I'm hoping that say 6 months.
And of course, some criticism that was leveled at it was the fact that it isn't totally free software open source. And so that would be nice for it to be totally free.
Well, obviously you still have some closed source. There'll still be the blob will still exist. It will get smaller. Video codec will stay under the management of the blob for the foreseeable future, and that's largely because you need the low latency. That code needs to run on the VPUs to have low latency access to the video codec registers. So I think where we'll probably get to quite quickly is a world where display and 3D are standard spaced. So display is DRM, KMS stuff, and 3D is Maser Gallium stuff. And then that functionality will get sucked out of the blob. What will be left in the blob is camera and video.
Okay, so it's the same interfaces, same everything for the camera and the touch screen. I can see it's got the analog audio.
Yes, it's still got analog audio and composite video. Yeah, we don't drop features. So, and of course the analog audio just got much better. I don't know if you've seen on the forums, but Jonathan's work on an improved sort of DSP code to improve the way we drive the PWM out of there has really paid off. there's a lot of ecstatic people on the forum saying, hang on a second, this is CD quality, just like you promised 3 years or 4 years ago.
So ecstatic without static.
Yeah, absolutely, without that constant thing. But no, it's good. It's good that that's got there because we always knew the hardware was capable of it, and it's good to see it actually realised in practice.
So is that going to be? And this is Raspbian thing. Is that going to be made the default?
Yeah, it'll be made the default. There are a couple of bugs left in it, and there are some issues with how it interacts with the DRAM calibration stuff. So effectively every twice a second, I think, we take the DRAM offline for some tens of microseconds to effectively calibrate the DRAM interface. The problem we have is that will tend to underflow. Various buffers in the PWM output will tend to underflow during that period because the DMA gets starved out. So we just need to come up with a story about how we're going to make that work. So currently we disable the DRAM PVT stuff when you're in the advanced audio mode.
Okay.
It doesn't seem to cause any problems actually, but it's not the right thing to do.
I presume if it was left on long term, it may surface in some situations.
Yeah, in some situations, but like I say, it doesn't actually seem to be doing any harm. So we'll come up with a solution. We want to do it the right way. But for now, people seem to enjoy it.
So in terms of layout, then it's going to fit in existing cases, is it?
It'll fit in existing cases, although you'll notice we've moved the LEDs. So the light won't come out if you've got a case with holes in it for the LEDs. The light won't come out. We really wish we hadn't had to do that, but as you can see, we've used that bit of board periphery for the Wi-Fi antenna.
I think that's a very fair compromise.
It is a fair compromise. I wish we'd put we all wish we could have put the LEDs. The LEDs could have gone there in the first place, right? if we'd known how precious board periphery was going to be 18 months ago, I think we would have put the LEDs down there in the first place.
And so is there going to be a new official case for this then?
Yeah, there is a new official case. So it's the same as the old official case, except prettier. It's just we've cut new molds. I think we've been fairly open about the fact that it was a pretty rocky road getting that case done, getting the molding for that case done. And the molds that we've used for the case for the last year are effectively, they're very bad molds. That have been rescued by some very clever guys in the West Midlands. They kind of did remediation on them, so they're good enough. The new official case is a whole new set of molds that we commissioned at the end of last year. So it just feels nice. It looks it's the same basic design, but with the LEDs moved. But it just feels nicer. There's a lot of refinement gone into it, so it's very much kind of version 2.0.
Very cool. And from a manufacturing standpoint, I mean, how long did your partners how much time have they had to ramp up to get ready for production?
Well, we've been ramping since the middle of January. We'll have between 200,000 and 300,000 units on launch day, which is fewer than we'd hoped for. We've had some supply issues from one particular supplier. You'll find out on Monday whether I've decided to name them in the blog post. I'm sorely tempted. A very famous semiconductor company, a very old and famous semiconductor company who have really dropped the ball in the most horrific and unprofessional way. Not any of the big bits of silicon, not Microchip or Broadcom or Elpida. We'll have 200,000 or 300,000. The supply chain situation is getting better, so we should have about 100,000 a week being built for as long as we need to. And we really should catch up. We can build 100,000 a week. We really should catch up with demand in a few weeks. We'll see how we go on.
And so does this explain the shortage of the Pi Zeros then?
To some extent. I mean, certainly there is no room in the factory in South Wales where we build the Zeros. I mean, by and large, the shortage of Pi Zeros is just because everyone bought them. We're selling everything we can make. We're into our third 100,000, is that right? So we're building another 150,000. So we're building as fast as we can, but we have had to take a little bit of a pause over the last month in order to get this done. So I posted on Twitter some pictures from the factory of zeros, lots of zeros in the middle of January of zeros being built. And of course, I was in the factory because we were ramping this. So those were kind of, those were some zeros they were squeezing out before the ramp. But
So can we return to the Wi-Fi and the Bluetooth? I mean, that is the killer here. I mean, the 64-bit processor is clearly important, but having Wi-Fi on it, there's been this demand for so long. I saw on the spec sheet earlier that it's 802.11n. Is that 2.4 and 5?
2.4 only, a single band 1x1n.
Right. Okay, fair enough. And what's the Bluetooth spec?
It's Bluetooth 4.1.
Okay.
Yeah, so it's Bluetooth Classic and Bluetooth Low Energy. So it's all the stuff you need, basically.
Yeah, great.
And are they tied directly into the Broadcom?
Yeah, so they're connected to Broadcom via an SDIO. Well, the Wi-Fi is connected via an SDIO interface, and the Bluetooth is connected using the UART.
Very excellent. So it means you're not using the USB side of it for
that. So it's incremental.
Network connection.
That's the nice thing. It's incremental bandwidth. So it's actually quite a nice. It ends up being quite a nice platform for bridging because. With the 1000 Ethernet, we have the Wi-Fi, which is 150 megabits peak theoretical, and then we've got some USB left over for mass storage. So if you're trying to bridge between wireless and wired and storage, it actually ends up being quite a nicely balanced platform.
Very excellent. And so, what kind of things do you think people will be able to do with this that they may not have been able to do before, or is it just it'll do it faster?
Well, it'll do whatever you're doing. There's a Simpsons, isn't there? There's the right way, the wrong way, and the max power way, which is the wrong way but faster. So yeah, it'll definitely be it's Raspberry Pi Max Power Edition. We'll be able to. There are two things people do with Pi, right? They use it as a PC or they use it as an embedded system, right? So if you're using it as a PC, now you've got the ability to get to the network wirelessly. You've got the ability to plug Bluetooth peripherals in. So you've got the ability to plug a mouse and a keyboard in. And I'm quite excited about the idea of people just sticking them behind a television. Now you can just stick it behind a TV and then just use Bluetooth for the peripherals. You can use Wi-Fi for your network access, and then so it's a completely wireless. It's a completely wireless solution. On the sort of embedded system side, Bluetooth sensors is a big deal. So I'm kind of hoping this has got kind of an IoT hub. A role as an IoT hub, which sits in your house, and then you have a cloud of Bluetooth connected sensors around it, and then use either the wireless or the wired Ethernet for backhaul out to the network. And of course, with the custom Pi stuff, you can then, if you develop a cool product based on that, you can either use the compute module route or the custom Pi route to take that to market.
So will the compute module be moved to Pi 3 architecture?
Yeah, so we're going to be talking about CM3 we're not launching CM3 on Monday, but we're going to talk about CM3. We've got some demos, we've got some prototype hardware. We'll launch that in the next few months. So we will launch that. We'll also launch 3A at some point this year. So kind of there are two MIA products, right? There's Compute Module 2 and there's 2A. Right? And all that happened there was the window just closed on them. We were selling so many 2Bs, all our chips were being sucked into 2B production. And by the time we got enough chips, it was November. And then this closed the window on it. This platform's going to be around for a little bit longer than Pi 2, so we can afford to roll out the CM3 and the 3 and the 3A, which I actually think has got real potential as a product because it's got the wireless on it.
It's getting the wireless.
It'll get the wireless, and so it's more convincing as a product, right? Because the single USB hurts you less when you've got wireless and Bluetooth.
Yeah, exactly. You don't really need Ethernet. You don't need more USB potentially.
Yeah, that's it. I mean, this one has been a hard program, right? I mean, the guys here have worked incredibly hard on it. Everybody in this office has worked incredibly hard on getting this one out of the door. And the wireless adds a layer of challenge to it that's never been there in a product before. But yeah, it's good. I think people are going to like it. I mean, the people who've played with it, there's particularly for the kind of PC world, there's a line, a required level of performance, and Pi 2 is a bit below it, and this one is a bit above it. It's kind of somehow that extra, it doesn't feel like 50 or 60% extra performance should make a qualitative difference to a product, but it really does, actually. And particularly because it's 50 or 60% single thread performance, where we had 6x from Pi 1 to Pi 2, but kind of 4x of that was the multi-core, and multi-core isn't always the easiest performance to access. Yeah. I was wondering what else is cool about it. H.265. So we don't have we haven't changed the codec hardware in there, but there is H.265 is getting quite popular now. So we've had over the last year a program to develop GPU accelerated H.265. So it's sort of a halfway house between hardware and software H.265, and that's coming along really nicely now. That can play all 720p. Content plays very nicely, and quite a large amount of 1080p content plays okay. So we're going to kind of over the next couple of months kind of push that over the line and really get all 1080p working.
So, as an example, who uses H.265 rather than 264?
So it's people who, I mean, it's very popular with people torrenting completely legal content. It's popular with people who want to optimize either their use of network bandwidth or their use of the storage on an NAS box. So theoretically, there's up to a factor of 2 improvement in file size for a given quality. Now, I think people are actually struggling to realize that at the moment, but at some point of the encoders will get good enough. Some of these features, it's all these things where we try and like the audio, we try and just push the ball forward. We understand the chip very well. Last year, for example, we added deinterlacing, high quality deinterlace, which is really useful for people watching often kind of sports content on there. So there's lots of things where, because we understand the DSPs and the GPU on there very well, we can really squeeze the performance out. And the extra clock speed that we've managed to get out of the GPU elements really helps with that as well.
So combining it with the camera video conferencing type situations or kiosk type potential uses?
Potentially. I mean, the encode side is H.264 only, but there's a lot of potential. So I think we're just going to keep squeezing and finding ways of getting more performance out of the device.
And so people might be surprised to see a new Pi already so soon after the Pi Zero. Is this it for a while then? You kind of implied that.
I think this is it for a bit. I think we've got to a good place. We've got to a level of performance which I think we're pretty comfortable with now. So I think we're probably we're gonna toggle back to that kind of what you saw from us in with the very long lifetime of Pi 1. So a lot of work going to a lot of work on the software side. So you saw a lot of work in squeezing performance out of a fixed platform. And I think we're probably going to, for the next year or two, we're going to toggle back to that kind of mode and really try and take this platform and squeeze everything we can out of it in terms of performance.
Something that I can't help but feel people might be slightly disappointed by is that it's only got 1 gigabyte of RAM. I mean, was that a cost issue to not be able to ramp that up?
Yeah, I mean, it's a cost and a chipset issue. I mean, I think this chipset is kind of at its limit now in terms of its ability to drive more RAM. It's a cost issue as well. RAM is RAM is a very substantial fraction of that $35. A gigabyte RAM is a lot of RAM. It's interesting. There are cell phone and tablet vendors who only ship a gig of RAM on their product still. And so I think one thing you'll see from us is some focus on memory footprint. You've always seen a focus on memory footprint optimization, but since we doubled the RAM last year, there hasn't been a bloat. There hasn't been a factor of 2 bloat in RAM usage, right? So I think we're going to try and squeeze that RAM and just optimize our footprint a little bit, which has always kind of been what we tend to do, right? We've always tended to throw effort at, if you save a kilobyte of RAM usage and you've got 8 million units in the field, you're saving an awful lot of RAM. You're saving an awful lot of money. And that's, when you've got an install base our size, you can justify doing stuff in software land that you couldn't if you had 100,000 units. in the field. So I think we're going to try and squeeze. And of course, you've got devices like Zero's only got half a gig, and we want to keep that viable. We want to keep the old B pluses and Bs viable, even the A's. We want to keep those viable as platforms. We don't want to throw them under the bus.
And speaking of the Zero, I mean, is there any possibility of a revamped version of that that's got wireless on board?
It would be nice. £100,000 of conformance testing and a whole heap of, there are some barriers between us and doing that. It would be nice though. There's also kind of board area. You'll notice that there's not a conspicuously large amount of free board area available on Zero to kind of fit those features onto. But it would be a fun thing to do, and it's certainly a thing that we, at least nominally, we at least know the shape of the. When we started doing this, we didn't know what the shape of the problem was. It was all unknown unknowns. Sort of Rumsfeldian unknown unknowns. We didn't know what the shape of the problem was. At least now we've done a product. We know what the shape of the problems are. We know what the hoops are you have to jump through.
So you mentioned software optimization. What kind of things are you working on at the moment?
Well, obviously there's the H265 stuff. There's some stuff going on around Neon optimize. There's Eternal. An interesting thing about the ARMs is if you go and look at any library and you look at the amount of x86 optimization, there is an enormous amount of. You go into a codec library and go look for SSE optimized fast paths in FFmpeg. Everything has been done. Everything has been covered. Right. The ARM world is still very sparse in terms of its optimization support. So quite a lot of the most effective money we've spent on software optimization over the last few years has been on things like FFmpeg and FFmpeg libav, Pixman, glibc. Lots of places where you can screw out a better mem copy. A better mem copy lifts all boats. So yeah, a bunch of that stuff. I mean, there are still things to do. This one has A53 has double width neon, so neon's kind of nominally you can see it as kind of a 4-issue. It does things 4 at a time, and then the underlying hardware doesn't have to be 4 wide. You can be 1 wide or 2 wide or 4 wide, and then it takes multiple cycles to do a 4 wide operation. The A7 has 1 wide neon, so 4 wide neon instructions take four cycles. This has 2 wide neon, so they take 2 cycles. This can mean that there may be some need for some rebalancing of various pieces of code which have been very, very finely tuned to run very well on the Cortex A7 1 wide neon. May need some rebalancing to run to squeeze all the performance out of the 2 wide neon.
Yeah, and obviously us here, we know exactly what neon is, but for the people who
for the people at home,
the ones at home.
Yeah. So neon is the ARM v7 era multimedia acceleration instruction set. So it provides provision for doing kind of parallel operations of various sorts, which are useful for things like media encode and decode and Pixman, so blit, color converting, blending, blitting operations. So we had on Raspberry Pi 1, we had an era of implementing VFP accelerator support. So there's a media acceleration instruction set associated with ARM v6, and there's another media acceleration instruction set, Neon, associated with ARM v7. There's another one, a kind of new version of Neon associated with ARM v8, but that doesn't matter because we're not running a 64-bit mode. So at least our ARM v7 optimizations will pay off on this core. But like I say, they might need a little bit of playing with just to squeeze the last 10 or 20% out of that. And we do a lot of squeezing the last 10 or 20% out. That's something nobody else does that. Because everybody else chases after new platforms. Because we're sort of sat here, we have a kind of a large market share. And we take quite a lot of the money we make from the Pi, and we do push it into doing that. We sort of feel that we can afford to do that, and it's in our interest to do that. And it's kind of fun because I'm a software engineer originally, so it's kind of fun actually to have a platform which is all about to a large degree, it's all about the software squeezing as much as it is about chasing down process nodes and pushing clock speeds.
there's the two sides to Raspberry Pi. There's trading and foundation. You're trading?
I am trading.
You're the man for trading. So
I am now.
When you're talking about funds, you're talking about the trading, spending money on
Yes.
product optimization rather than the education. Okay.
Yes. So effectively, the for people at home, the corporate structure of Raspberry Pi, we have the top co is a charity, Raspberry Pi Foundation. It owns 100% of the shares in the one share in Raspberry Pi Trading Limited, and Raspberry Pi Trading Limited is a regular commercial company. Our mandate is to go out and make money for our shareholder. We just have an unusual shareholder. So the kind of the flow is money comes into Raspberry Pi Trading. We recycle. We spend about between a third and a half of it inside. Well, I was used to say a half, but now, since we've started selling more Raspberry Pis and we haven't hired engineers fast enough to catch up, we're spending about a third of it inside the Raspberry Pi trading organization, and we return the remainder up to as dividends up to the foundation, which then spends it on doing awesome educational stuff.
Very excellent.
Yeah, which is cool. And of course, one of the big changes this year, we've hired Philip Colligan to be our chief executive for the foundation. And he's 100% awesome. So you're really going to see the foundation do amazing stuff over the next couple of years.
Yeah, it definitely looks like, and from the foundation side, that it's really stepped up its game and is out there a lot more.
Yes. Yeah. Really.
And not just going to America.
Yeah, not just all of that. Yeah, they've all run off to America. So as you know, most of the foundation is in the US this week, doing our first Pi Academy USA with our partners at the Computer History Museum in Silicon Valley. But yeah, obviously particularly since the merger with Code Club, we have a lot more. Yeah, we have a lot more resource. We have a lot more capability to go and do awesome stuff. Which is great, because that's why we're doing it.
Yeah.
Ultimately, although it's enormously good fun selling lots of little computers. It's nice to sell them for a reason.
Yeah, I listened to I think it was a video interview a while back where you mentioned the camera module and the fact that the sensor is you have to bulk buy the sensor.
Yes.
Is there some work happening on a replacement
future? Yeah. When we run out of existing cameras, there will be new cameras. We still have quite a lot of existing cameras, but there will be new cameras. We've identified a successor, a worthy successor to the OV5647. It's annoying that went EOL
so soon after it was introduced.
Well, yeah, absolutely. I mean, it's annoying when that happens, because what you find. I mean, when we do engineering work here, what we like is for the engineering work to translate into benefit to the customer. And if what you're doing is working around the obsolescence of one of your suppliers, the best possible case is you do a load of engineering work and nothing changes. that's the optimum outcome, and that's really galling, because it's hard and it's not cheap. But yeah, we found a worthy successor. We don't think there'll be any disruption from moving on from 5647. And we had a good run. I mean, we must have done 300,000 or 400,000 of those 5647 modules. They've been very, very popular. People have used them for a lot of stuff. So we had a good run. I think we got a solid 18 months, and then the EOL, and then whatever we could, maybe another year to 18 months out of the bulk buy that we did at EOL time.
Well, thank you so much for taking the time to talk to us about this and for inviting us up here to see it. And I can't wait to get home and fire it up and have a play with it.
Yeah, absolutely. Well, thanks again. And I just hope people like it.
I'm sure they will.
It was so great to meet Eben. He was definitely flitting around getting things done. There was a huge amount of activity in the office, even though a bunch of them were off at already left for the US for Pi Academy, and it was really good to get a bit more details on what's happening with the Raspberry Pi Foundation and the Pi 3.
And what a cool office, eh?
It was very nice. It still had that shiny new smell going on, and there was still people in there lifting the elevated floors to put cabling and things in there. So I expect they're going to be making great use out of it.
Yeah, and such a relaxed atmosphere in there. I mean, as you said, there weren't that many people there, but the people who were there weren't many suits and ties, were there? It was all very casual and just, it seems like a really cool place to work.
Absolutely. So if you have applied for any of the jobs that they've got out there, it looks like a good place to end up.
Yeah, definitely.
So, Joe, as you mentioned on the interview, you have a Pi 3.
I do.
Did you get a chance to play with it?
Yeah, I've had a chance to play with it, and it's faster, is all I can say. It's faster, and Wi-Fi is decent. I was worried that it's not got much room for an aerial on there, but you're still getting decent 50, 60 plus megabits per second, which, it's not exactly 5G AC speeds or whatever, but what do you want for a $35 computer? I'm very impressed with the Wi-Fi performance and performance in general.
Yeah, and because it's on the Wi-Fi is on a different bus, I suspect, and again, I haven't had a chance to play yet, but I would suspect it'll be faster than the USB dongles because it's not bound by USB.
Yeah, I think it is a touch faster from my tests. I mean, I haven't had a thorough chance to play with it, and we're recording this before Monday, obviously, and so I haven't had a chance to play with the final Raspbian image, but it's looking good already. And as Eben said, it's only going to get better. They constantly refining the software, aren't they? And they keep pumping out the new versions of Raspbian and tweaking it. So given that basically a very crude hack of the old image with some firmware files in it has produced a perfectly working, much faster Pi, I can't wait to see what they do in the next week or two and indeed the next few months with the tweaking to make it just super, super fast.
Yeah, and as you said as well, it's not on the USB. So it's not just they've got a USB dongle, ripped it apart and stuck it on the board. It's on a completely different bus. And so is the Bluetooth, which means the USB ports are still full bandwidth for everything else. Yes, they're still shared with the Ethernet port, but for most people, USB is going to be dedicated because you won't need the Ethernet with the Wi-Fi.
Yeah. And I've done some quick tests of Scratch and stuff, and just everything is faster as you'd expect. It's a beefier processor. Everything is faster.
So what kind of test did you run on it?
Well, I did hard info, which comes up as system profiler and benchmark in the menus, and that's got various benchmarking tools on that, and it was consistently 50-60% faster than the Pi 2.
And that's great. And again, what I'm loving is, as you said, they got it because it's a better 32-bit processor. So it means that everybody, for all of the existing code, everything should run, all of the games that were being given away free by some of the publishers should all run better as well. And then, in the future, the headroom exists for 64-bit code. So I know with 1 gig of RAM, that mightn't make much of a difference in initially, but it looks like the architecture itself has the ability to be even better and giving even greater performance from the Pi 3 in long term.
Yeah, the thing about the ARM v8 is that it will run ARM v7 code. So it's kind of an analogy is if you take a modern laptop that's got an x86 64 processor, it'll run 64-bit code, and most operating systems are 64-bit, but you can still run a 32-bit operating system on it, no problem. And so with the Raspberry Pi, it's ARM v8, but it'll still run ARM v7, no problem.
Yeah, because I've already started with the Pi Zero doing any development I do on the Raspberry Pi 2. And then at the end, sticking it into the Pi Zero, mainly, to be honest, because of the convenience of having the extra ports and the access. And, it's kind of easier for me to work in that environment because I've got that fairly much set up. But I can see with the Raspberry Pi 3, even if you're going to be putting something on a Pi 2 or a Pi Zero or, some other version of the Raspberry Pi that Eben mentioned maybe coming out soon, then it makes it logical that the software will just work. You do your code on the fastest version of the Raspberry Pi you've got, and then you put it on the other one for, when it's going to be in use.
Yep.
And he mentioned the board layout and the LED being moved. I mean, I know for people with lots of cases, that'll be a problem. So where are the new LEDs?
Well, they've moved slightly across to the corner where the power jack is, the micro USB power supply. So they haven't moved much, but yeah, if you've got an existing case and you really need the LEDs, then that could be a bit of an issue. But I'm sure that new cases will come out in a day or two.
Yeah, I'd expect the Pimoroni guys will have their cases already. There'll be new a Pibo and what do they call them, the flotilla colors. So the coupe, that's it. So the coupe case, which is the one that I go for these days because it's got the GPIO exposed. So it protects the Pi itself, but you can still get at the GPIO pins very easily. So I expect they'll have their case ready the moment this is out. And was there anything else you tried on it?
Well, I actually tried Ubuntu Mate on it, and it didn't boot. I just got a rainbow screen. And so I put the SD card back in the Pi 2 and did rpi-update, well, sudo rpi-update. It took 4 or 5 minutes to update the firmware, put the card back in the Pi 3, and boom, it booted. And it's faster. It's a desktop machine, basically.
On Ubuntu Mate, did you try running any of the applications? You know, the desktop performance, as Eben said, you know, this is in his view above the line where desktop performance is appropriate.
Yeah, I mean, I'm not sure yet. I think that there's going to be some tweaking required. It was definitely faster and it was definitely more comfortable, but you know, compared to my i5 and i3 machines, it's a long way off. But I think that it is usable, definitely. And web browsing on it is much, much nicer in either Ubuntu Mate or in Raspbian. And yeah, I think it has crossed that threshold, as he said, that it does feel usable. I mean, it's still a slow usable machine, don't get me wrong. It's not super fast compared to x86 machines, but it is definitely usable.
Well, it's amazing what they can do with a $35 computer.
Yeah, it really is.
So on Raspbian, did you try Scratch or anything like that? Because again, you know, the educational world, Scratch is where it's at.
Yeah, I did try Scratch. I tried the Pac-Man demo, and that is much, much faster. It's much smoother and faster. So that really bodes well, I think, for Scratch stuff.
Yeah, definitely. I mean, the Pac-Man game, I think, is a great inclusion in the standard image because it really thrashes it. I've run that on some of the older Pis as well, and it's torture. And then you put it on a Pi 2, and it's playable. And it sounds like on a Pi 3 now, we're at full speed, which is perfect.
Yeah.
I'm excited to get one. I'm going to be trying to get one on the first day. So hopefully there's enough in stock and I get there early enough to get them. Because even with Eben mentioning, I think it was about 300,000 at launch, I still expect it'll be sold out. So I expect there'll be some people who'll be disappointed on the first day.
Yeah, I think there will be. But it sounds like they've got production ramped up to a point where they will be able to fulfill demand. And hopefully it's good news for the Pi Zero as well. I think there'll be people finally getting both of them in a week or two.
Yeah, I saw that the retailers in the UK with the Pi Zeros were still selling out. So there's still a pent-up demand, which imagine having the choice, do I get myself a Raspberry Pi 3 or do I get 7 Raspberry Pi Zeros? It's going to be a dilemma for some people.
Yeah, definitely.
So with that, Joe, I think that's fairly much it. The information that we have so far, really looking forward to seeing how people use it and the optimization that's coming down the line. But yeah, welcome to the new world of the Raspberry Pi. We've got a Raspberry Pi 3 to play with.
Yeah, and I can't wait to see some 64-bit stuff going on. And it's just opened up a whole new world of development and excitement, I reckon.
Yeah, I'm waiting to see what the Imperial College in London guys do, because they've done some bare metal coding on the original Raspberry Pi, and they've shown some amazing demos. So I wouldn't be surprised if they're first out of the gate with the 64-bit code as well.
Yeah, and just imagine how fast Riscos is going to be on this.
I don't think I'm that fast. I think it'll be too fast for me. It'll be brilliant. That's going to be a thing to do. I want to see the video. I want to see a video of something running on it. You know, the original Elite running on this, I have a funny feeling it could be close to unplayable due to the sheer speed.
Yeah.
Fantastic.
And so with that, then, we're coming to the end of another Pi podcast. If you want to get in contact, you can email show@thepipodcast.com, find us on Twitter, Facebook, YouTube, Stitcher, iTunes, or leave a comment on the website. Thanks for joining me, Albert, and thanks for everyone for listening. We'll see you again in 2 weeks, and this time we mean it, with more Raspberry Pi news, interviews, and discussion.
Take care.
See you later.